Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about converting sum of product SOP into canonical or standard SOP. We know that we can have a Boolean function in SOP form, that is sum of product. But all Boolean function which are in SOP form are not canonical. And we know that to be a canonical SOP form in Boolean function, we should have all the literals of all the variables in each product term. So now we'll see and we'll follow certain rules to convert SOP into standard or canonical SOP. We have rule or step 1. From each product term, find the missing literals, if any. We have number of product terms in our Boolean function, and in each product term we have to observe that whether there is all literals are available or not. For example, we have y is equal to a bar plus abc. Now we can observe that in the Boolean function we have two product term, first and second. In first product term we have a bar b, and in second product term we have a dot b dot c. So now we can see that in first term literal c is missing. The first step is to identify that whether any literals are missing or not. But the given example, it is a SOP form of Boolean function, but it is not a canonical or standard form. So we follow step number 2. Prepare a sum term of missing a literal and its complement. We have just seen in the example that literal C is missing. So as per step number 2, we have to prepare a sum term which consists C and its complement. So C plus C bar. In case of OR operation, we know that A plus A bar or B plus B bar, that is equal to 1. Because literal of C was missing, so as per step number 2, we have prepared a sum term which consists a missing literal and its complement. So C was missing, so we have prepared a sum term which consists C plus C bar. Now step number 3, multiply this sum term of missing literal and its complement with the term in which it is missing. Now we have to multiply. As I said, in OR operation, C plus C bar, that is equal to 1. So if we multiply any product with 1, then product remain as it is. There is no change in the value. So we have to multiply this sum term in the product in which it was missing. So again, in our same example, we have multiplied C plus C bar, we can see at this stage, with first product term, that was A bar plus A bar dot B, and we have multiplied C plus C bar with the first product term. Now step number 4, use distributive law of Boolean algebra and expand the term. And last, eliminate repeated term if any. In case of OR operation, we know that A plus A, that is equal to A. So we can eliminate repeated terms. Again, in the same example, A bar B dot C plus C bar plus ABC. So in second term we are not going to do anything, but in the first term we have to multiply A bar B with C, again A bar B with C bar. So A bar BC plus A bar B C bar plus ABC. Now we can see that we have, instead of 2 product terms, now we have 3 product terms, and in all the 3 product terms we have literals of all the variables A, B, C, and that is why this type of Boolean function we can see that we can say that it is a standard or canonical SOP. Now let us see one example, then you can do practice on your own. Suppose we have one Boolean function with 2 variables f of AB, and that is equal to A dot B bar plus A bar. So we can observe this Boolean function that it is a SOP form, that is sum of product. Here we have sum term and we have product. But we can see that in the second term B literal is missing. So we have to prepare one term, sum term of missing literal, that is B plus B bar, and we have to multiply, or we have to end operation in the product in which it was missing. So our equation becomes A B bar plus A bar, and this term B plus B bar we have prepared and we have multiplied with the A bar because B was missing. Now if we expand the term, then it becomes AB bar plus A bar B plus A bar B bar. So now instead of 2 product terms, again we have 3 product terms, and we can see that in all 3 product terms we have all the literals. We can say that it is now in canonical SOP form, standard SOP form. Let us take one more example, f of ABC, and that is equal to ABC bar plus A bar B plus BC. So it is a Boolean function with 3 variables, and we can observe that in second and third product term some of the literals are missing. So in the second product term C is missing, A bar B, so C is missing. In the third term BC, so we can say that A is missing. Now as per next step, we know that we have to prepare a sum term of missing literals, sum term that is missing literal and its complement. So again we write our equation ABC bar plus A bar B. In the second term C was missing, so we have prepared a sum term C plus C bar and we have multiplied with the A bar B. Same way in the third term A was missing, so we have prepared a sum term A plus A bar and we have multiplied with the BC. Now if we expand the term, then it becomes ABC bar, A bar B C, A bar B C bar plus ABC plus A bar BC. In the equation we know that A bar BC and another A bar BC both are repeated terms, so we can eliminate one term and we can write our equation as ABC bar plus A bar BC plus A bar BC bar plus ABC. Now this Boolean function is in canonical form. Once it becomes a canonical, then we can write in terms of min terms. So now let us proceed to prepare the Boolean function to be represented in min terms. Up to this stage we have received standard SOP form. Now we go for min terms. Now if we write binary equivalent of each product term, in case of SOP form, we know that a product term, if it is a variable is complemented, then we have to write 0. If it is uncomplemented, then we have to write 1. So for example, first term A, B, C bar. So we have to write 1 for A, 1 for B and 0 for C bar because C is complemented. So our first term becomes 1, 1, 0. Same way A bar B C. So it becomes 0, 1, 1. A bar B C bar. So it becomes 0, 1, 0. And ABC, that becomes 1, 1, 1. So we can write 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1. Now if we write decimal equivalent and in terms of min terms, so we know that for 110 decimal equivalent is 6, for 011 it is 3, for 010 it is 2, and for 111 it is 7. So we can write this product as M6 plus M3 plus M2 plus M7. Small m, we know that it is for the min term, and 6327, that is decimal equivalent to the binary number. We can rearrange the function and we can write as M2 plus M3 plus M6 plus M7, and that can be written as summation of M. Sigma, we know that it is for sum of product, so we call it summation M, small m for min terms, 2, 3, 6, 7. So this way we have prepared our SOP form into canonical or standard SOP form, and then we have proceed to convert it into min terms. So now function f of ABC can be represented as summation m 2, 3, 6, 7. So meaning is now it is in canonical standard form, and we have min terms 2, 3, 6, 7, and for that product terms we get output high. Thank you very much for watching my video. Keep watching. Thank you very much.